In this question, a compound microscope is given. The total angular magnification is given as 30. The focal length of the objective is given as 1.25 centimeters. Eyepiece focal length is 5 centimeters. How will you set up the compound microscope to get 30 as the magnifying power? Setting up of a compound microscope demand the lenses to be placed at what distance? The distance between the objective lens and the eyepiece. Then from the objective lens, what distance the object to be placed? So these are the 2 points we need to know when you set up a compound microscope. First point, distance between the objective lens and the eyepiece. Then second point, from what distance the object should be placed from the objective of the microscope. So basically, object distance we need. This is the distance of the object from the objective lens. And we need the distance between the two lenses. That is BO, the image distance of the objective, and the magnitude of the object distance of the eye lens. The image distance of the objective lens and the object distance of the eye lens. So values given, if you collect, the total magnifying power is 30. Objective focal length is 1.25. Eyepiece focal length is 5 centimeters. Generally, the near point distance is taken as 25 centimeters. That normally sometimes not given in the question. Now, from this, the M is actually product of magnification of the objective and that of the eyepiece. General formula for M is V by U. So MO is equal to VO by U minus VO by U because the image is formed upside down by the objective lens, inverted image. ME, that is actually VE by UE, but for a microscope, we already proved ME can be shown as 1 plus D by F. Magnification produced by the eyepiece, it acts like a simple microscope forming image at near point. The formula is 1 plus D by F. So in this, we have D and FE, so you can find ME. After getting ME and M, you can find ME. So ME is equal to 1 plus 25 upon 5, that will be 5 plus 1, 6. Now using that 6 for ME and M as 30, you get MO as 5. MO is actually minus VO by UO. So if you substitute 5 here, you get 5 as the ratio of VO by UO with a negative sign. Get VO from that. VO is equal to minus 5 UO. Now you can substitute this value in the lens formula. 1 by VO minus 1 by UO equal to 1 by FO. In that VO can be substituted as minus 5 UO. So 1 by minus 5 UO minus UO equal to 1 by 1.25. So take LCM. You get minus 1 by 5 UO minus 1 by 5 by 5 UO. Right hand side you can change as 1.25 as 125 by 100. So on solving, minus common, 6 by 5 UO equal to 4 into 25 is 100, 5 into 25, cross multiply and find the value of U. The 5 get cancelled, UO equal to minus 6 by 4, 1.5 centimeters. So the object to be placed 1.5 centimeter on the left side of the objective lens. One part is fine. Now we already know VO is equal to 5 times of UO with negative sign. So 5, again negative, so 5 into 1.5 is 7.5 centimeters positive. So we got VO also. Now if you are getting UE, then the question is done. For that, you have to go for the lens formula for the eyepiece. They didn't given where is the image formed finally. Normally, compound microscope, the image is formed at near point. So the image is 25 centimeters on the left side of the objective lens. So we put the minus 25. F is already given. F is given as 5 centimeters. So same way, you can find UE. So use the 1 by VE minus 1 by UE equal to 1 by F. So 1 by VE is minus 1 by 25. 1 by UE equal to 1 by F is 5. So if you transfer the terms, minus 1 by 1 by F, 1 by 5 plus 1 by 25, minus 1 by 25 become 1 plus 1 by 25. Then you take LCM, becomes 6 by 25. So UE will be minus 25 by 6, will be minus 4.17. So now you got UE and VO. The distance will be VO plus magnitude of UE. VO already we have 7.5 centimeter here. UE is minus 4.17. We add the magnitude of both 7.5 plus 4.17. We get 11.67 centimeters. So the lenses to be placed 11.67 centimeters apart, with the object to be placed 1.5 centimeter behind the objective lens. This is enough. If in case they've given the final image is formed at far point, in case. So that time the image is formed at infinity. For an image to be formed at infinity, the object has to be at the focus. That means UE will be equal to FE, which is 5 centimeters. So again, the distance between the two lenses will be VO plus UE. VO remains same as 7.5 centimeters. You add 7.5 with the 5 centimeter, that's a 12.5 centimeters the distance between the two lenses. So two possibilities, 12.5 centimeters the distance between the two lenses, and the object to be placed minus 1.5 centimeters. So this is one answer. This is the second part of the answer. If the image is formed at near point, if the image is formed at infinity, this is supposed to be the distance. So the two possible adjustments for the telescope, microscope.